Let's take a look at problem number 4 on page 605 in the notes and see another example of a separable differential equation. So now we have the dy dx is equal to x plus 2 over y, and we're given that f of 1 is equal to -3. So let's see what we've got. First thing we're going to do is we're going to cross multiply to get the x's and the y's separated. So that gives us y dy is equal to x plus 2 times dx. And now that we've separated this equation, we can take the integral of the indefinite integral of both sides of the equation. As always, pause the video and see if you can go through these steps. If you're a little nervous about whether you get the right answer or not, then do it on a scrap sheet of paper and then just fill out the worksheet when you double check your work against mine. So the antiderivative of y would be y squared, and then we need to divide by 2. And then the antiderivative of x is the same thing, 1/2 x squared. The antiderivative of 2 is 2x. And then I'm going to add in, like I said over here, when we do this, very often, just out of a sense of casualness, we're just going to add a single real constant to this equation instead of thinking about having 2 on both sides, because it's just one real number when we get down to it. Maybe I'll clean this up a little bit and multiply both sides of the equation by 2. That's a fair thing to do. It's the same relationship between x and y when I do that. Might make my numbers a little easier to deal with. X squared plus 4x, some real number times 2 is just still some real number. It's a little lazy for me to not write down 2c, but yeah, it's all the same in the end. And now the last thing I want to do to solve for c is I'm going to substitute in 1 for x and -3 for y and see if I get a solution for that. So -3 squared is equal to 1 squared plus 4 times 1 plus c. -3 squared is 9, is equal to 1 plus 4 plus c. So that's 5. And so subtract 5 from both sides. I get c equal to 4. And so the equation that satisfies, it's not an, well, it is an equation. It's not really a function, plus 4x plus 4. Okay, so that's another example of how we're just kind of easily able to solve what looks like a complicated differential equation just by separating the variables and then taking the indefinite integral of both sides. The next problem on the back of the page is going to be a little bit trickier. We'll see what happens with it.